Okay, so let's finish this up. This is where it gets a little bit trickier, I suppose. Not entirely, but I mean, there's just a couple things that make it a little bit harder, especially the example down here. But basically, we're going to be doing the same thing that we did before. Before we had an exponential function that we were trying to solve, and we would take the logarithm of both sides to make it work. Now what we're going to do is we're going to be starting with a logarithm, and we need to be able to take the exponent, or we're going to exponentiate is what we call it. So over here, let's just get right into this example. It says log base 5 of 3 to the x minus 8 equals 2. Well, what we're going to do is we're going to exponentiate each side by using whatever the base of the logarithm is. So we're just going to do, our base is going to be 5. Okay, so the idea of this is that we can get rid of our logarithm fairly easily just by simply raising each side to whatever that base of the logarithm is. So in this case, it's 5. So therefore, we're going to have 5 to the log base 5 of 3x minus 8. And again, this is all in the exponent. I know that it's a little small. So 5 to the power of log base 5 of 3x minus 8. And then we also have to do 5 to the second. So both sides have to be exponentiated with 5 as the base. On the left, the 5 and the log base 5 will cancel out. So all we're left with is 3x minus 8. On the right, we have 5 squared, which is 25. Add 8 to both sides, so we have 3x equals 33. Divide both sides by 3, we get x equals 11, so the solution is 11. Okay, so added 8 and divided each side by 3. Okay, so hopefully that makes sense. Try this on your own. Hit play when you're ready. Okay, so hopefully you got x equals 68. Again, because the base was 2, we raised both sides. We exponentiated by putting 2 to the power of on both sides. The 2 and the log base 2 canceled out for x minus 4. 2 to the 6th power is 64. Add 4 to both sides, you get 68. Okay, let's look at a one that's a little bit more difficult. So on these ones, again, here's where we have two separate logs. And in the last section, we talked about how to condense our logarithms. So before we solve anything here, we need to get it to be one logarithm. So what we have here is we have addition. Because we have addition, it means that we're going to be taking this one and multiplying. So we're going to do 5x times x minus 1. So this is going to end up being the logarithm of, I do 5x times x is 5x squared. And then 5x times negative 1 is minus 5x. So we have the logarithm of 5x squared minus 5x equals 2. And again, the reason why we multiplied them is because we were adding. That's how we condense logs. If you're doing addition, then you're taking this and multiplying by this. And so I did 5x times x is 5x squared. 5x times negative 1 is negative 5x. So now we go through the same thing. Now, there's no base here, but that means that your base is 10. You have to remember that if there's no number there, then the base is just 10. So we're going to exponentiate both sides. And actually what I'm going to do is, we'll save some room here. I'm going to put a 10 here to this power. I'm going to put a 10 here to this power. So we have 10 to the power of log base 10 of 5x squared minus 5x. We have 10 squared, which is 100. So these cancel out. So we're left with 5x squared minus 5x equals 100. Yes, we have quadratics. Does that suck? I'm sure you guys think it does. But unfortunately, math doesn't just go away each chapter. We still need to be able to solve quadratics. So this is 5x squared minus 5x. How do we solve? We get it all equal to 0. So this will be 5x squared minus 5x minus 100 equals 0. Then what I'm going to do is we're going to factor. And we're first going to factor out a 5. So we're going to factor a 5 out. So we're left with 5. And then we have x squared minus x minus 20 equals 0. Keep factoring. Factors of this are going to be negative 5 and positive 4. So we have 5 times x minus 5 times x plus 4 Okay? So therefore, the solutions that we come up with are x equals 5 and x equals -4. Now, you do need to try these. So you have to put these back into your equation to see what works. Now, we haven't really talked about this in detail, but we have explained that the domain of a logarithm is x is greater than 0, meaning we cannot have negative numbers. We cannot take the logarithm of a negative number. So right away when you see this -4, if we try and plug this back in, we're going to get undefined or an error. So therefore, we have to get rid of this. So the only thing that ends up working is our x equals 5. Okay? So again, do this one on your own. Do this one on your own and see what you get. Okay? And then hit play when you're ready. And this is not a minus. I'm sorry. This is not a minus. It's a dash. So this is just 1/3. So I'm going to keep this separate. Okay, so hopefully you got an answer of 1,302.083. The first step here was to multiply by 3 on both sides to get rid of the 1/3. So when you did that, you ended up with 6. Okay, and so then what we did was we had base 5, so we had to exponentiate, put both 5 to this power, 5 to the 6th power. You got 12x equals 15,625. Divide by 12, you get 1302.083. Okay, so don't forget to take your Edmodo quiz. Get that done, and I will see you in class.